Hey Condors, it's your boy, Mr. Roberts, coming at you live with a little bit of social distancing science. Hey, before we get started today, go ahead and click on the subscribe. And once you've subscribed, don't forget to turn on notifications. Hit that thumbs up as well and like this video. So let's get started with a little science. Go to your waffle and go to McGraw-Hill. And we're starting off with encounter the phenomena Earth's motion around the sun. Now, this is asking us the question, what causes the weather to change in the same pattern every year? Now, we've seen how the weather in the same location can vary and change throughout a year. In the images below, let's look at the northern hemisphere. Use the information provided for the first image to infer the information for the second image, and we're going to record our reasoning for our answer. So, the season is summer, and the expected weather is warm to hot, temperature depending on location, longer days, and shorter nights. What do you think the season's gonna look like when the Earth is tilted? Notice the difference? In the summer, the Earth is tilted one way. In the other season, it's tilted differently. What season do you think is going to be occurring? What do you think is going to be expected weather, and what's your reasoning? Hit pause, answer this, and then let's continue. Okay, we're gonna watch a little video to see this in action. Ooh, a very nice winter paradise. Oh, it's spring. And now it's summer. The trees are fully leafed out. It's beautiful. Oh, and the leaves are starting to fall, which means it's fall. How nice. Okay, we're going on to the next assignment, which is our investigation, night and day. So, how does the Earth move? If you look outside at the ground, trees, and buildings, it does not seem like Earth is moving. Yet, Earth is always in motion, spinning in space, and traveling around the sun. Earth's motion changes how energy from the sun spreads out over Earth's surface. Let's investigate further. Have you ever thought about the causes of night and day? Hey, I've got a demonstration. Give me a sec. Let's watch that. Oh, look, we're here in the classroom. And I've got some props here with me. I've got a the sun. And if that's the sun, what do you think this is? Oh, that's right. It's my makeshift globe. And we have our friend Mr. Stickman. So where on this globe do you live? If you answered North America, you're right. Let's go ahead and put Mr. Stickman on the globe to represent where he lives. And let's go ahead and turn on the sun. Okay, so Mr. Stickman is currently facing the sun. What time of day do you think it is? Now, as the day progresses, the Earth rotates. What time of day approximately is it for Mr. Stickman right now? Is it daytime or is it nighttime? Now we're back to Mr. Stickman pointing at the sun. Based on the rotation you've seen, how long has Mr. Stickman been on this planet? Okay, go ahead, record your observations and hit pause. Ooh, turn that sun off. And we've got another question. Do you think every planet in the solar system has night or day? Why or why not? Um, Again, hit pause, answer this, and then let's continue. We've got one more thing we're going to do today. So, how does the Earth move? Let's find out a little more. So, as Earth moves around the sun, it spins. A spinning motion is called rotation. Some spinning objects rotate on a rod or axle. Earth rotates on an imaginary line through its center. The line on which an object rotates is its rotation axis. Suppose you could look down on Earth's North Pole and watch the Earth rotate. You would see that Earth rotates on its rotation axis in a counterclockwise direction from west to east. One complete rotation of Earth takes 24 hours, and this rotation produces Earth's cycle of day and night. Earth moves around the sun in nearly a circular path. The path an object follows as it moves around another object is called an orbit. The motion of one object around another is called a revolution. Earth makes one complete revolution around the sun every 365.24 days. Now, why does the Earth orbit the sun? The answer is the law of universal gravitation. This law states that the pull of gravity between two objects depends on the masses of the objects and the distances between them. The more mass either object has, or the closer together they are, the stronger the gravitational pull. And Earth's rotation axis is tilted. The tilt of Earth's rotation axis is always in the same direction by the same amount. This means that during half of the Earth's orbit, the north end of the rotation axis is tilted towards the sun, and during the other half of Earth's orbit, the north end of the rotation axis is tilted away from the sun. The sun's effect on Earth's motion is illustrated above. Earth's motion around the sun is like the motion of an object twirled on a string. The string pulls on the object and makes it move in a circle. If the string breaks, the object flies off in a straight line. In the same way, the pull of sun's gravity keeps the Earth revolving around the sun in a nearly circular orbit. If the gravity between Earth and sun were to somehow stop, Earth would fly off into space into a straight line. Okay, hope you're having a great day. I'll see you again on Wednesday.